Hey everyone, Mr. Wader here, and today we're going to be going over Lewis diagrams. Lewis diagrams are pretty similar to what we did yesterday, only they're a simplified version of a Bohr diagram. So basically, the outside ring of the Bohr diagram, which showed you the atom's valence electrons, is the only thing that we are going to use for the Lewis diagrams. Now, it may seem like it's a waste of work to do the Bohr diagram, or that these are too simple, but both of them have their uses. Bohr diagrams do a better job of showing you the electrons for the whole atom. So if you're trying to figure out why something is working differently than expected, that's pretty useful. But for a lot of the purposes in regular high school chem, we only need Lewis diagrams. So that's because the valence electrons are the ones that actually do bonding. And since bonding is what happens during reactions, that's what we care about, is the valence electrons. So just like in the last video, the group number is what we're going to use to figure out the number of valence electrons. And then our goal is to draw those valence electrons with the element symbols to find the Lewis diagram. And the Lewis diagram will help us with figuring out the shape of molecules, how things will bond, how many bonds things can make, etc. So the way that you do a Lewis diagram is first you have to find out the group number. So first one is lithium. Lithium is element number 3, and it's in group 1. Since it's in group 1, that's the number of valence electrons, that means we only have one valence electron to draw. So lithium gets one valence electron, and we draw it as a dot. The number of dots that you have in the picture should equal the group number. So everything in group 1A should have 1 dot. Everything in group 2A should have 2 dots. Then we skip all of the transition metals. You go to 3A, which is 13. All of these should have 3. 14, 4A should have 4. 15, 5A should have 5. 16 and 6A should have 6. 17, 7A should have 7. And 8A should have 8. Except for helium, because helium is the weird one and it only has 2. Okay, so that was the first example, is lithium. Next up is silicon. Before I forget, I'm going to write the group under it. Group 1. Okay, so silicon is element number 14. It's right here. And that makes it 4A. So I'm going to just say group 4. And if it's in group 4, it means it has 4 electrons. When you are counting these out, it actually matters where they go. So the way that we're going to do that is clockwise. So you're going to start at the top. You're going to go to the right, bottom, left. And since silicon only has 4, we're done. Well, what happens if you have more than 4? So oxygen is in group 6, which means it has 6 valence electrons. You start by counting out the same order, top, right, bottom, left, but we still have 2 left. So we're going to add 1 at the top, 1 at the right, and then we're done because we used all 6. What you'll notice is that sometimes they'll pair up like this. When electrons are paired like that, it means that they are not going to bond because they're a lone pair. They're already paired up, and you do bonds by pairing up electrons. We'll go over that later. But for now, making sure we can do these drawings is the important part. Next up is chlorine. Chlorine is element 17. It's right here, and it's in group 7A. Since it's in group 7, that means it's going to have 7 valence electrons. So we're going to count out using the same method. 1, 2, 3, 4, 5, 6, 7. You'll see that there's 3 pairs of electrons and there's 1 free electron by itself on the left there. That 1 electron, you're going to learn more about later, is an electron that can make a bond because it's by itself. All right, and last up for the examples for today is neon. Neon is element number 10. It's in group 8. And I'm referring to like 8A, just like all the other ones, right? Like 7A was chlorine, 6A is oxygen, etc. So this is group 8A, which means it should have 8 valence electrons. So we're going to do the same thing. Top, right, bottom, left. That was 4. Top, right, bottom, left. And that uses up all 8. Neon is a noble gas, which means that its outside shell is always full. It's got 8 spaces here. You'll notice that's the most we can fit because we're at the end of the row now. After neon, we would go back to sodium, which is back in group 1, and you would have started back here all over again. So if you were to draw an example of every example, you would see that group 1 has 1 dot, group 2 would have 2, group 3 has 3, etc. All right, with that, if you have any questions or there's anything else that you feel like you need to know, feel free to leave a comment on Google Classroom, send me an email. Your assignment for today is to try and do these examples at the bottom here. I'm going to post a video later with the answers after this is due. And yeah, I'll give you the answers next time. Hope this video was helpful, and I'll see you then.